Yeah, very good afternoon. Hello.
Hello, sir.
Yeah, is it audible?
Yes, sir. You are audible. Your PPT is visible on screen.
Okay, okay. Shall I
We'll
start then now?
start in a 1 minute. We'll introduce you and then you start the session.
Okay, okay, okay.
Thank you, sir.
Okay.
Good afternoon to all present here on virtual dais. Today's resource person, Mr. Pradeep Joshi, our Principal Dr. Sanjay Bukade, and Vice Principal Dr. Sanjay Deshmukh, Head of Mechanical Department, Dr. Rajesh Kale, teaching, non-teaching staff, and all the participants. I, Professor Ratnam Gujar, on behalf of MCT's Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering, welcome you all for the second session of AICTE sponsored online 1 week short-term training program on recent trends in energy management and audit. Today we have resource person for this STTP, Mr. Sandeep Joshi with us. He will speak on energy saving opportunities through condensate recovery. I take opportunity to introduce our today's resource person, Mr. Sandeep Joshi. He has completed his BE in Electrical and Electronics Engineering from Malwa Institute of Technology, Indore, and MTech in Engineering Management from Devi Ahilya Vishwavidyalaya, Indore. He is currently working in Evergy Projects Limited as a Managing Director and Group President. He is also consultant for Energy Efficiency Services Limited with a past experience in Veolia, JLL, Immersion, and Lemon Tree Hotel Company. His expertise in overall energy management, right from identification of energy conservation projects, renewable energy systems, power quality, power distribution, solar energy, and green buildings. I welcome you, sir, and thank you for joining with us today. I request you to enlighten us with your words of wisdom. Over to you, sir.
Hello.
Over to you, sir.
But I think I am Pradeep Joshi. There was something mentioned. Somebody mentioned Sandeep Joshi.
No, sir.
Okay, okay. No issues. Okay. I am Pradeep Joshi from Energy Projects Limited, and this is an environmental energy. So first thing is that I need to ask you, all of you, how is the Josh? Hello.
Hi, sir.
That is what I'm expecting, because everybody is possibly maybe online, or maybe you may be in the classes. So I wanted to ask you that question.
No, sir, we are there.
How is the Josh? If the Josh should be higher. Okay. Okay. As far as the topic is concerned, like energy conservation from condensate recovery system. Next. See, the scenario is that little background of that particular part. What really is happening is that this is mainly. I just wanted to know that are there mechanical engineers?
Yes, yes.
Okay, okay. So and chemical?
Chemical.
But mechanical are there.
Mechanical are there.
Okay, then
most
they
of
can
them are
understand.
mechanical.
Okay, okay. Then they can understand much better. Okay. Basically, what's right now happening is that the oil prices, then fuel prices, because the import and other things, they're fluctuating so high and low. They're looking at that. It is very pertinent that every company is thinking to cost cutting, and how these things is going to happen. Particularly when we are talking about boiler, this is the main heart or the pain area of any industry which is having boilers or utilities. That's their main area of concern, and cost also. You can say that in average cost of utility is between 45% to 65% if the boiler and other things are there, apart from their raw materials and other things. So looking at that particular part, what really happens is that I have seen right now that many industries we have seen that this is the most neglected area of condensate recovery. So the by if I go by a thumb rule, 72% is said to be a good one. Ideally speaking, overseas, if you look at European countries and UK countries, UK, the percentage of even if they can touching to 89 to 90%. But in India, if you ask this question to industries, they normally give a very ready-made answer that we have 62%, 60%. There because they are not serious about that. See, the great philosopher called Mr. Peter Drucker, he said that don't maximize your profits, reduce your losses. Reduce your losses, actually. So it is very important that we need to identify the losses and need to, because rather than profits, anything, so that kind of things are always there. So looking at that, what really happens into this is, we are not looking towards what losses avenues are there actually where we can reduce our losses. And when you reduce your losses, automatically your profitability can go up. So look at fuel prices, which are already increasing, and cost of steam. Now this is fluctuating, but if you take it right now, say cost of steam is rupees 4 per kg for a liquid fuel fired generation, and maybe rupees 2 per kg for gas or solid fuel fired generation. Now this waste of steam or hot condensate spills into direct losses. Now these losses, how they take place, and everybody, I'm sure that they know the basic boiler philosophy, how it works. The boiler, I'm not getting into that part, how boiler works actually. So directly going into the condensate. Now, whenever the steam is going to the reactors or steam is going to many such different kind of applications, when it gets converted into a liquid part, actually, what we call talk is, or what we refer is as a condensate. The prime challenge, what normally which we face, our industries are facing, is how to reduce the fuel bills, how to reduce fresh water bills, and how to reduce ETP bills. Definitely, there are a lot of answers. That's why we even conduct, whenever we used to conduct a thermal audit as a part of energy audit, or even a water audit as a part of sustainability initiative, the answer is, of course, is heat recovery from the condensate. So how far we are able to do that? Now you can see the graph also, which is being given on the right side bottom, which you can see, is that if the we can see that what kind of losses would be there and what kind of savings will be there. So you can see the graph that water is 30 degrees Celsius, water is 100 degrees Celsius, water is at 180 degrees Celsius. How is going to be the steam actually? How it is going to behave? I already shared this particular presentation also with Dr. Kale, Rajesh Kale. So this is also available with you. So even afterwards also you can see what I'm talking. Am I actually talking speed is okay?
Yes, sir.
Okay. Okay. Because that's very important that whatever I'm talking, that should get into the, reach to the people who are audience. Next. Now, when we see that why this condensate is generated, then we say that it can be recovered and used it again. Now, as we say that the boiler generates the steam from water for the process heating. After the steam has been given up its heat to the process, it condenses back into the water. What we say is which has got heat of 20% of the steam heat level. Now, when we see this particular part, actually, one is that I'm not going to get into the chemistry of that, but we say sensitive heat is already there along with the steam, along with the condensate. So it is totally distilled water with lots of heat, say at the 3.5 kg per centimeter square, contains approximately 144 kilocalories of heat per kg of condensate. And if this hot water is fed back to the boiler, it reduces the amount of heat required to the heating it back to the saturation temperature. Now, if we say that in part, for every 6 degrees Celsius rise in the feed water temperature will increase the boiler efficiency of 1% by 1%. This means that fuel consumption of the boiler will reduce. This is right, exactly the fuel reduction and the cost actually is very important into this, which plays an important and critical role. And as we say always that condensate water is actually a pure water. It has got very low TDS, less than 20 mg per liter, we can say. And it is excellent boiler feed for water from chemical point of view also. We get that kind of condensate also from the multiple effect evaporator, but the TDS level is not so low as we can get it from this one. That we can, we expect around 200 mg per liter of TDS. TDS is total dissolved solids. So that really is a villain of your either boiler feed water, or I can say that even multiple effect evaporator also. So when the condensate has got a lower TDS value, the return condensate to the feed tank reduces the effective feed water TDS. So TDS, as I said, that all water treatment, everything is a villain is TDS. And due to that, it reduces the blowdown losses in the boiler. Now, when we go to the industries, they talk like that. Okay, sir, we ask them question that what is the blowdown your percentage? What is the blowdown percentage? And what is the blowdown frequency? So I have seen even the good boiler where they have twice in a month blowdown. And I have seen a boiler actually where they are having, sir, every shift mein kar dete hai. Every shift we are doing blowdown. So that kind of thing, frequency of blowdown depends upon what is the water quality and what kind of TDS you are getting into that particular part. Okay. So that kind of things are there. So monitoring the boiler performance, actually, that also is very important from the level of that key, what kind of quality of steam you are getting, what kind of quality of condensate you are getting. And third one, which is a very important part into is this, that more is the TDS, you are going to have more problems and your blowdown frequency will increase. Your makeup water requirement also will increase. And that will also affecting the entire boiler efficiency of again indirectly also and directly also. It will also affect the cost of your treatment, cost of your steam, that will get changed. Next. Now, why heat recovery from condensate? That's very important part. Now, what we say is already is a condensed water after giving away the heat. So what we call this as a is a old word, but it's called as latent heat in the heating process. So being condensed from the steam, it is very pure water and best possible source for feed water also for the boiler. This quality feed water directly results into reduction of blowdowns, as I already shared with you, and the resultant heat losses through the blowdowns. Yes, any questions? I'm not teaching here anything. I'm just sharing what I have learned. Okay, I have been learning for the last 35 years, actually. So I'm just sharing here with you. Now, in addition to this particular most important feature is we say medium and high pressure condensate that carries with its significant amount of, we say, just now I mentioned about that sensible heat, what gets wasted in the moment we drain the condensate. Now, what is normal practice in the industries? What they do is that whatever it depends upon, of course, of the area of the plant also, any industrial facility, that they say 8 reactors are there. I have seen even companies having 375 reactors. So all these reactors have got a facility where the steam is supplied, and while entering, rather while introducing either cooling water or chilled water, what normally they do is that they blow down the entire, take out the flushing of the condensate from all the reactor jackets. And then when it comes down, it is collected into some kind of a tank. And then from the tank, they transfer. And from transferring to one tank to the another one, then they ultimately reaches to the feed water tank of a boiler. Now, what happens into this particular part? Normally, the condensate temperature is around ranging between 84 degrees Celsius to 90 degrees Celsius. What happens into this particular part is that when they transfer this, what is the conventional process? When there is no condensate recovery system, what is the conventional process? What they do is that they transfer this to tank to tank, and then ultimately feed water tank of the boiler. While doing that particular part, the temperature, let us take that 85 degrees, 84, 85 degrees Celsius temperature. it falls down to 64, 65 degrees Celsius temperature. So this 20 degrees Celsius, average, we let us check that 20 degrees Celsius temperature. Already I have said that how much heat we have losing from that per kg of a condensate. So what really happens next to that is that because of that 1 degree, each 1 degree Celsius, the boiler also the efficiency comes down. And second part which comes out is that it is a costly affair that the temperature being fallen from 85 degrees Celsius to 64, 65 degrees Celsius temperature. Heating of that particular part again to the the steam, that is really a costly process. It is time-taking process. Third thing is also it brings down the overall efficiency of a boiler in generating the steam, and the cost of the steam which is added into the product cost, that also goes up. Now what they do, what is the other option into that? This is how the option goes into that. If we are going to get into this condensate heat recovery, now condensate heat recovery we can do. One thing is that condensate you have recovered and you are again using into that particular part. Now you have a temperature of around 64, 65 degrees Celsius temperature, but then heating time and the money and the fuel which is required for that purpose, that goes up. Now, in addition to this particular part, as I said, that the sensible heat which is gets wasted movement in the drain of the condensate. This is as shown in the the previous graph which you have seen, the demonstrated graph alongside, which is already been given into that. The 20% of the total heat of the steam and can be recovered by this way, that controlling, that is controlled flashing and return of the condensate to the boiler feed water tank at 100 degrees Celsius. Now, how it can be done? Next. One thing which is going to come, but I'm also in referring that particular part. How the condensate is pumped back to the feed water tank or even to the tanks also, if they are using centrifugal pump. Now centrifugal pump cannot handle the higher temperature condensate, and then it gets into the trouble of maintenance. The people who are mechanical people, for them, I have little, particularly maintenance side, whoever the people go, I have little bit, some space in my heart for them, because maintenance people, they do a thankless job. I'm not discouraging anybody to not to get into the maintenance job, but frankly speaking, maintenance people are never appreciated. When the plant is running well, the people say that it is running well. The production people say that it is running well. Yes, we are there. But when it gets into trouble or some maintenance problem comes, they say that these maintenance people are good for nothing. So who are close to the management, top management, these are the production people, not the maintenance people. But I believe that the maintenance people, and I mean jokingly, I say that maintenance people should never marry, because they have two wives. One is their home who is there, and then in the plant, that is their production people. Actually, they are after them. That I cannot give your time, but I want the plant should be maintenance free. There should not be any problem. Just humor actually. So coming back to this thing, that what really happens into this is if we are using, so in when you are using a centrifugal pump, you are using power, that is electrical power you are using. Then you are using again a centrifugal pump which cannot be operated at a higher temperature, which also gets into trouble. Maybe after 6 months or so, you have to keep a standby pump also to bring back the condensate to the tank and feed water tank of the boiler. Instead of that, can't we know to do that particular part? Can we use? Now two things are there into condensate. There is a pressure, there is a steam also, one of the part, and second is a condensate, that is liquid part. Now it has got latent heat also, and which is normally wasted, and that's why the temperature falls down from 85 degrees Celsius to 64, 65 degrees Celsius. Can I use a pump, which is steam operated pump, and bring back that particular temperature, actually not falling that temperature? So what really into this happens is that this condensate is collected and it is flashed, as the meaning is the flashed, into a vessel. While doing that particular part, the condensate goes down as being a liquid, and the steam comes up, and then what we system is provided is called a flash steam condensate recovery system. So basically, we are flushing that steam and generating little bit, creating a kind of a pressure itself by the steam. And then we are using the same steam for running the pump so that I don't have to use an electrical operated pump, centrifugal pump. I can use a steam operated pump, saving that much of power. Second, the maintenance problems are going away because of the centrifugal pump is not being used for that particular purpose. And I'm using also the steam. If I want to use that steam, I can use it. Sometimes some processes require 3.5 kg, 4 kg steam also. I can use that steam also over there if I don't want to use it into other applications. So I can use it, different applications I can do. I can use that particular pump for by steam operated pump, or I can use that steam also. If I got some process requirement, I can use that low pressure steam also over there. Now, presently, some industries, condensate is collected in the collection tank as I was sharing with, and after it is pumped to the conventional electrical operated centrifugal pumps, which I was talking about. And as I shared with you, 15 to 20 degrees Celsius temperature drop happens. It is stored in the collection tank or storage of that particular part, because many times I've seen that it is not properly insulated also. Now, while the condensate treater pump, condensate water, which is pumped soon, which is already getting filled, so there is no significant temperature drop into this particular part. So I would say that if the temperature of this particular condensate is 84, 85 degrees Celsius or even 87 degrees Celsius, there will be maybe, maximum 5 degrees Celsius temperature will be dropped, maximum 5. Otherwise, normal our experience indicates that 2 to 3 degrees Celsius temperature drop is there. Now, this electrical pump also requires frequent maintenance, which I shared with you already. While condensate return pump have only float type of moving part, which is fit and forgot type, because there is nothing like, you really have got a lot of moving parts into that. This is another advantage to that. And then electrical pump faces the problem of dry running, that is cavitation, what we call it as a. Due to the higher vapor pressure, while the condensate heater pump will never have this kind of problems. So cavitation is another problem which takes place. And if that pump is not really having, what we say VFD or that kind of systems, then this particular pump will there's always a danger that this pump also may get burn out. Now, electrical pump again faces cavitation, which I mentioned, and then pitting problems also, while condensate pump will never have this kind of problem. Next. Now, as a condensate is returned to the boiler feed water, it reduces the amount of makeup water. This is a very important part, because previously water never used to be taken as a serious business, and even accounting for that also was never taken into. Whereas this has been right now, everybody talks about water as an input raw material, and it reduces cost of water treatment. It influent treatment also. Condensate recovery system will make the combination of flash vessel, condensate recovery pump, and deaerator, because this is also very important part. Now, what is flash vessels? Am I okay with my speed and the pronunciations and everything?
Yes, sir. Yes, sir.
Okay, because you are my customers, and customers I got a simple definition. कष्ट करके मरता है, वो customer होता है. Okay, just a minute. Any problem is there?
No, sir.
Okay. So, what is flash vessel? The flash vessel, what we say, is used to separate condensate with a flash steam from the condensate return line. When the high pressure condensate is discharged from the steam traps, I will talk about other things also into this. This is not only a one kind of system which can take care of that. As I already told you, that is a combination of flash vessel, condensate, and deaerators. So this energy which is coming from the trap, that is pressure condensate return lines, the excess energy which is released in the form of flash steam. This flash steam can be used for the heating of the boiler feed water and for low pressure steam applications. As I shared with you, certain companies need low pressure steam also, and they don't want to provide extra system for this generating steam. That particular parts are there. Next. Now, when we talk about condensate heater pump, the condensate heater pumps, which is having no, as I already mentioned, that it has no moving part assured, zero maintenance. Then condensate heater pump utilizes the flash steam that is part of that. And condensate heater pump suitable for high temperature application as far as concerned, and no cavitation problem into this particular part. Then this pump, which has got steam consumption at a very low pressure. Condensate heater pump, which can be operated on a compressed air also. It can be operated, these are the options which are available. Condensate heater pump, automatic venting of air and non-condensable gases, that also can occur into this particular part. That's why it is very easy. Easy monitoring for condensate heater pump operation can be checked right from the providing a sight glass. Sometimes we also provide a multi-view system where you can monitor that particular part. Sometimes some deposition comes up, so that can be taken care of. Then condensate heater pump, which can say various sizes of different capacities. Maximum capacity we can expect even 12,000 kg per hour. So that also can be done. And then it can be, a very important part, it can be skid mounted. So sometimes it happens that we are thinking for some future processes are there where we are thinking that the system can be location can be changed, modified. So that also can be done into this. Okay. So this can be given on skid mounted. You can see the photograph also after this. Next. So now, how is the operation? Condensate from process will be collected in a condensate receiver tank, and due to the gravity, it will be due to gravity. That is what we prefer always. It will open the inlet check valve and start filling the pump. By this time, the steam inlet valve is closed, vent outlet valve is open, so that there is no back pressure, and this will lead to the float rising from the level L to the level H. Now, it is in pre-pumping mode. As the float reaches to the level H, logic control unit shut off the vent valve and open the steam inlet valve. This will allow the pressurized steam to move in the pump and push the water level in the downward direction. See, this understanding of this operations also is very important and critical. A good assets are wasted because the people don't have knowledge. By this time, we say the delivery check valve will be open and inlet check valve will be shut off.
Ryan.
Now the pumping mode. High pressure steam condensate to the delivery line, and this will lift the condensate to the main boiler feed tank. While doing all this kind of thing, as I said, the temperature drop is between 2 to 3 degrees Celsius only, maximum 5 degrees Celsius. Now this pumping mode, which will remain until the float reaches to L level L. Now, after doing this particular part, as float reaches to the level of L, the logic control unit will shut off the steam motive valve and opens vent valve to remove the gases. Now, these gases can interfere into our entire operations also. This is very important. By this time, the delivery check valve will be closed and inlet check valve will be opened, which will again allow the condensate to fill up the pump. Again, first mode will be operated after this mode. Now, normal case, what is the difference between this and the other thing? It is coming over there, condensate is collected, and then by the time it happens, as I said, that the heat losses takes place. To avoid that, whenever things are coming, this will get operated, and it is operated always by steam. So that's an advantage into this system. Next. Now, why this particular pump instead of conventional electrical operated pump? Already, as I said, shared with you that 15-20 degrees Celsius, there will be a losses and there will be a significant temperature drop. And electrical pump consumes more electricity, while condensate recovery pump consumes only 2 to 3 kg of steam for pumping 1 ton of condensate water. This is very less comparison to electrical consumption, that if air is used as a motive pressure, then 0.3 kilowatt per ton of water. that will be used. This is a comparison between the electrical pump and air pump as well as the steam pump. Electrical pump requires a frequent maintenance already shared with you, while condensate recovery pump have only float type of moving part, which is fit and forget type. Electrical pump faces problem on dry running, cavitation problems, vapor pressure problems. Condensate recovery pump will never have this kind of problems. And electrical pump cavitation, as already shared with you, pitting problems. Next. Now this is flash and condensate recovery system. As you can see, that which I shared with you is the operations of the entire system. So typical, this is a typical flash and condensate recovery circuit. As you can see, the top, the control valve is there, the steam is coming. The you can see that condensate recovery that is returns to the water tank. This is a pure water tank. It is coming back over there. Then you have a flash vessel. As you can see, the flash vessel. Then flash vessel steam to the low pressure applications. It is going there, and you can see there is a receiver. So that's coming to the receiver. There is a pump, you can see. Receiver is there. And then you can see the flash system is there. Now, it is how it is coming from the plant. It is already indicated. That is the heated medium that is coming. And then the pressurized condensate is coming from the plant. And then it is flash inside the flash vessel. The steam is going to get operated. The steam also is going to operate the pump. Or if you want a low flash system, low steam operation applications are there, you can use it there. And then you can transfer the condensate to the feed water tank of your boiler. Next. You want to see this particular part again? Can we go back? Can we go back? Huh. Everybody has understood this circuit?
Yes, sir.
Yes, sir.
Okay. So shall I go ahead?
Yes, sir.
Otherwise, somebody wants to see that also, they can see that also. I'm just giving a couple of minutes. Because this is the heart of the entire system. Because here you can see the circuit. What I'm showing you next, the thing is that actually the equipment I'm going to show you. This entire system I'm going to show you. But that's a photograph. So the understanding circuit will be much better for all of you. Am I correct? The moment you say go ahead, then I will go ahead.
Yes, sir. Go ahead.
Okay, thank you. Next. This is a system which you can see. Lower part is the receiver. The upper part you can see is the flash vessel. And you can see the pump also down there. So pump is also there. That is a steam operated pump. And you can see that this is a prefabricated frame. So I can take it to the plant. I can just install it. I can connect it and forget it. This will start then. So such kind of frame is there. What you can see is the skid mounted. That is, there are wheels also. We can give a wheels also down there. If they want to take it for some other systems also, they make some modifications. The framework which has been given here, the mechanical framework is given just to increase the strength of the entire system. Otherwise, there is no any other purpose for that. Next. Now you can see the steam operated pump there. Right side, you can see the steam operated pump. The compact model, as you can see, that is 25 to 40. And the smaller one, you can see down there, low capacity, we say is called as a mini pump, which can return a small quantities of condensate, even from the remote locations also. Sometimes what happens, the plant size is quite large. So sometimes when you have a larger area, I'm talking footprint point of view. it may not be possible that you can have this system at centralized location. So what you can do in this particular part, you can have these small pumps actually operated over there. The cost also comes down and recovery is better. So simple in construction, as you can see, the operation operated by steam, and so highly economical and energy efficient. The pump hot condensate practically at 100 degrees Celsius also, and high energy saving. Supplied as a self-sustaining skid mounted system with all required accessories. Laptop much. So supplied as self-sustaining skid mounted system with all required accessories like receiver tank, as you can see, that receiver tank, and valves, strainers, motive steam, inlets, connections, that particular part. Next. Now, steam separation flash vessel. Basically, what is flash vessel? Nothing but it is separating steam with the condensate. That is, steam is there along with the condensate. That is getting separated. Recover the heat from the condensate by flashing the condensate using flash system at a required low pressure, designed based on the area of separation required for efficiently separating steam from the condensate. Normally, we collect the data from the clients that all this kind of basic data. Based on that only, we have designed this particular systems. Now, this flash system, which is used for separation of flash steam from the high pressure condensate, and thereby low pressure system. So low pressure steam totally is a free of cost. The flash system, which is there actually, which has got standard accessories, as I already shared with you: a safety valve, pressure gauge, wall, double window side glass. Now, this double window side glass, this is also a very important part of this. Sometimes it gets deposition from inside. So again, maintenance problems come. So that's why it has got a double window side glass. So it is very clear. And the double window side glass is also given in such a way that whenever the condensate is coming, the direction are given like that. The condensate will clean the glass from inside. Now you will find that many such side glasses have been given. There's no cleaning system inside. Every time you have to open that particular part and clean that particular part. Okay, so that is very important part. So safety valve is given, pressure gauge is given, valve is given, double window side glass is given, and very important part is a steam trap and a strainer. So that is given. That is given. So strainer flash system. Now how it works also I will share with you. Okay. Right. So that has been given. Now can we go to the next? Have you understood this particular system?
Yes, sir.
Yes, sir.
The point is well taken.
Yes, sir.
Now, how many people have heard all these words actually previously? Hello? How many people are acquainted with these words which I am using?
Sir, we have 10 to 15 faculties who are listening carefully to what are you saying, sir. So we are listening carefully.
No. Why I'm saying, how many people are acquainted to the word terminology which I'm using? Terminology. I'm talking terminology.
Sir, it is streaming on YouTube, sir.
All of them are knowing about this terminology because they are mechanical engineers.
No. Why I'm asking these particular questions is that something which I use, and somebody has got some doubts. Definitely we are going to have a question and answer after this, but I don't want to see that it goes unnoticed. So
No.
anybody has got that kind of things, I should, because
Okay.
sometimes it happens actually. Anyway.
So whatever doubts they are having, immediately we'll let you know.
Okay. Now Coming to the steam traps. This is just an example. Along with these systems are not there if it is missing. Steam traps are always there into the other things also. But apart from in condensate recovery, which we are talking, the steam loss through a half-inch bypass cap, say 1/4 open, only of at a 3 kg per square centimeter square pressure, then a half condensate with a half condensate and only half steam going out. What is the calculation for this? So 9 multiplied by 0.5 multiplied by 24, 108 kg per day is the steam loss. That is, if you take it, number of hours, days actually working for that, 108 multiplied by 300, that is 32,400 kg per hour of steam loss. If I talk about revenue per kg, even if I take, depending upon the what kind of fuel feedstock, fuel feedstock is there, it will be either multiplied by 4 or multiplied by 2. So just imagine what happens if you have got just 5 open trap bypass system in your plant. I was in one of the plant near Roha, MIDC, in Roha MIDC. The consumption of this particular plant, I mean, they have around 18 tons, 10 tons, 12 tons boiler. They have got 5 boilers. And I just asked a question to their GM works that what is the condensate recovery in your company? Because I could see that everywhere I can see the traps actually, there were a lot of losses taking place. So I asked them, what about the condensate recovery? He said 0 recovery. Forget about the 62%, 65%. He said 0 recovery. You know what is their consumption, water consumption per day? That's 1.5 mld. It's a 1.5 mld is the water consumption. And you can imagine that there are 5 boilers. And if the 5 boilers are there, how much consumption they must be having? And what condensate recovery? Instead of that condensate recovery, that entire condensate is going to the ATP. And they have established a big ATP for that particular purpose. So there are heavy losses on that particular account also. Not only the MIDC is supplying them water, but there are heavy losses of water, heat, consumption of water, also the chemicals, everything is happening there. So I would say that we normally say to the client, always the companies, that please use the right kind of trap and stop this kind of trap bypassing from opening that. Next. Now these are the different steam trap modules. The modules are fitted with we say strainers for continuous non-choked operations and multi-view for operation monitoring, online monitoring. Multi-view system, as I said, that it has been designed from the point of view of there should not be, of course, there won't be any choking as such, but to ensure that there is no depositions of the salts or any kind of things, and you can see clearly how it is passing that particular part. So these are different modules which have been used actually for steam trap modules. Next. Now, return of condensate. As I already shared with you, that return of condensate to the feed water tank saves money, but use a CF pump, that is centrifugal pump, restricts the condensate temperature. Not more than 65 degrees Celsius, you can get it from that. And this is again due to the cavitation. This means loss of, we say 35 kilocalories per kg of condensate, which is to be returned. This means of 94,000 rupees per month for 24 hours running plant, consuming only 1 tons per hour of a steam. You can see this kind of scale which is there. So it is, I would say that it will be a 3 to 4 salaries of the utility department. Next. Now this is a model for a steam operated condensate return pump. There's a receiver and there's a pump also which is operated by steam. Now this, we say that saving this particular 94,000 rupees per month, straight away just return it into the 1 tons per hour of condensate. Next. Now we have a case studies. Till right now, if you have any questions, you can ask me because I am starting now to get more understanding that how it works. And I have some case studies which I will be focusing on case studies now.
There is one question. Are there any methods or devices that are available to calculate condensate recovery?
Yes, one is the heat. How much heat you are getting? That is temperature. And second is the flow meter. Normally, companies don't use flow meters. I don't know why. What is the reason behind it? To just it's not deviation from the subject, but to just give you. I was conducting a water audit for a company near Thane, and I found that the flow meter which the MIDC was supplying them was having only was rather reading air plus water. That means the flow meter was calibrated for air plus water, not for only water. Per day, this company was losing around the quantity of that, the air which was coming through from MIDC to this particular plant. They were having around 9.5% of air just coming along with the water. And the flow meter was indicating. So if when I calculated that how much is the quantity of water is coming and how much is the air by calibrating a water to water flow meter, I found that 9.5 to 9.8% was air was coming from the MIDC, and they were charged for that particular purpose. So per day, average if I take it, 10%, the company was having around the inlet, I would say the requirement, that is water demand, was approximately around 1.2 mld. Now imagine 10% if they are taking the air, their effluent which was going there, actually they are charged by CTP, common effluent treatment plant, as per the basis of consumption of water, not on the basis of discharge of the water, on basis of that particular part. So this company was losing every day 40 to 42,000 rupees per day just because of that. Now coming to this particular point, how we can do that particular part? So condensate, the heat which is there actually, which you are recovering from the condensate recovery system, and the flow which is quantity which is coming over there. So whether you can calculate the efficiency of condensate recovery system, that's why I said when you say 62%, 60%, you can go up to, as I said, that ideally you can go up to even 92% of that. But to be precisely, we can say that 72% minimum is said to be a good condensate recovery. I'm talking quantity point of view. Okay. As far as the temperature is concerned, I would say the temperature, falling of temperature of 2 to 3 degrees Celsius, I would say is that's okay, it's acceptable. Any other questions?
No, sir.
Okay. Shall I go to the case studies now?
Yes, sir. Please.
Okay. Now you will see that how calculations are made. Okay. How calculations are made, that you said just now that how is there any method? So that I am going to show you that how investment, that is cost benefit analysis, how it is done. So case studies is going to give you insight on that, the savings in terms of economics as well as the quantity. So we will go into that particular part. So now we'll start the case studies.
Hello, sir.
Yes.
Hello.
Yes. We are just sharing the case studies.
Okay, okay.
Can everybody see? Can everybody
Yes,
see?
sir. Yes, sir.
Okay, these are real case studies. These are not make-believe stories. That's why we have mentioned even the company's names also. Okay. Now, is it okay?
Yes.
Yes, sir. Yes, sir. It is okay.
And some talks are going on behind you. That's why I said. Okay. Now, if you look at this is the company which is the Babti Food Industries. For any kind of system, we first do a kind of a assessment of that company. We just don't go to the company that okay, we'll give you this system. So we have to understand their entire utility operation, mainly in terms of boiler and steam. Now, this particular plant, existing equipment using steam, plant has got around 5-stage flake dryer with steam usage capacity of around 800 kg per hour. And present steam usage is around 500 kg per hour. Steam is used in coils with every stage having a separate coil. So there are 5 condensate outlets, and the condensate from each outlet is being drained to the atmosphere. I think being a mechanical engineer, you must have understood the heat transfer. Okay. Now here, outlet being drained to the atmosphere. I don't think this is only money going out, but it's a crime. Energy management point of view, this is a crime. That is what we believe. So this plant has got these 3 cookers to cook the corn, and total 15 batches are being cooked per day. After every batch, the excess steam of 2 to 2.5 bar pressure is vented directly in the atmosphere from the cooker. Now, it was therefore decided to work on these 2 fronts. Two fronts. One is that, of course, at a time to efficient the draining part and the return condensate from the dryer to the field water tank, and to recover the heat of the vented steam from the cookers, along with the arresting and reducing the it was also having a lot of noise also, and because of the venting of the cookers from the cookers. Now, how we started our implementation? 5 numbers of continuous discharge type steam trap module have been installed for a proper condensate removal from the dryer outlet. This is a steam trap which we have given a little different name. Has an online cleanable strainer. Now, this is very important. The strainer should be online cleanable. There is no need to take it out, shut down, nothing. So it should be online cleanable strainers. Before the trap, to protect the trap from the being choked or leaked, and double window side glass, which I already shared, after the trap, to monitor the performance of the trap. And these accessories help in continuously uninterrupted functioning of the traps. Now, this is also very important. Now, when silencers were designed and installed along with the cyclone separators for each of these cookers to effectively reduce the noise of the steam exhaust. Actually, implementation, when we talk about steam, it is not only a steam, but it is also what it has got along with that. It's a kind of a package, what we always think. A 500-liter hot water tank was designed and installed, and the vent from the silencer is injected into the hot water tank to generate hot water. This is nothing but whatever energy recovery you can do. This is more customized. We don't have a formula that if you have got this, I will give this. So we have to have a customization. This hot water is then pumped back to the boiler feed water tank using a steam operated condensate return pump. Now, 1 number of common steam operated condensate return system which has been installed to recover around 400 kg of condensate per hour from a dryer, and hot water from the cooker at the rate of 500 kg exhaust of cooker at the maximum available temperature. Next. Now let's see this monetary savings. 4,80,000 multiplied by 540 multiplied by 1.5. The total saving is 1,334 per day. That is 540 kilocalories per kg is a latent heat of steam at atmospheric pressure, and 1.5 is the cost of steam per kg. Even if you take it very small one, it will not go down, it will go up only. Now running cost. 3 kg of steam is required to transfer 1000 kg of condensate. Now the cost of operating steam operated pump is 3 multiplied by 16 multiplied by 1.5. That is 72 rupees per day. Total saving minus operating cost, therefore saving is 1334 minus 72 is 1262. Saving from return of hot water generated from cooker vent, how much it is going to be there? The 500 kg water being heated from 30 degrees Celsius to 80 degrees Celsius from every vent of batch. Therefore, the saving is 80 minus 30 multiplied by 500 kg multiplied by 15 batches. They are taking that way. So it is 3,75,000 kilocalories per day. Now monetary saving, 3,75,000 divided by 540 multiplied by 1.5. So total saving is 1041 per day. Now where 30 degrees Celsius is the atmospheric temperature of water, 540 kilocalories per kg is the latent heat of the steam at atmospheric pressure, and 1.5 is the cost of steam per kg. We normally take 2 or even 4 kg depending upon the feedstock which you are using. Next. And we say the steam loss will be possible practically in the absence of flow meters. The steam loss is considered and the saving would be much higher. Next. Next. Now, heat loss of around 3 kilocalories per kg. Now, steam trap module has been installed at 14 numbers of steam using equipment for proper condensate removal. Steam trap module has been online cleaner strainer, which is the trap to protect the trap for the getting choked or leaked. So total investment of the trap module is 2,80,000. So we say 20,000 multiplied by 14. Saving steam which will be getting wasted through a leak traps and open bypasses, which is normally there, which we have seen many plants. I have seen plants even today they are being put up maybe a year back or 2 years back. I have seen similar kind of problems there. So steam operated condensate return system, including flash vessel for flash recovery, which has been installed to recover condensate at a maximum level temperature. Steam operated condensate return system comes with a buffering sub receiver, which is already shared with you. Therefore, the common condensate collection tank is not required. Both condensate and flash is returned to the boiler filled water tank. Next. Now savings are 12,000 minus 648. So this is 11,352 per day. Total investment is, you can say, 2,80,000. That is trap model plus 4,51,000. That is condensate and flash system. 7,31,000. The recommended implementation of steam energy conservation pays itself back 7,31,000 divided by 11352 is 64 days only. This is a payback period. The people, the boys or girls, those who are going to join some industries, they need to take it granted, or they need to consider that anywhere your payback period is less than 2 years is said to be very good. Anywhere you are saying that the payback period is going to be 3 years or 2.5 years, your management is going to say thank you very much. They are not going to implement it at all. Here, you can see the return of investment is 2 months only. Next. Now, the steam operated condensate system, which is there. Sorry. Oh, I see. Now, this is company called Ganesh Remedies. This is in Ankleshwar. Now, what we have done into that? What about the company? The plant has got around 8 reactors and 3 dryers. Steam trap model 6 numbers of 15 NB and 5 numbers. These are actually our codes. Actually, 5 numbers of 20 NB have been installed for a proper condensate removal. Steam trap module has an online cleanable strainer before the trap to protect the trap from the being choked or leaked. and double window side glass. As I said, that this is a part of the system. The total investment of the trap modules is around 1,60,000. That is 60,000 plus 1 lakh rupees. Efficient steam trapping and condensate removal. No need to open bypass for condensate removal. Therefore, no direct steam losses. Steam operated condensate return system, which has been installed to recover 1400 kg condensate per hour from the plant at a maximum available temperature. And most of the other similar plants, the condensate being drained and fresh water being used in a boiler feed water tank. The investment of condensate return system, 1400 kg per hour capacity, 1,46,800. 1,46,800. Now saving. Condensate is recovered at 90 degrees Celsius instead of 30 degrees Celsius. That is fresh water. Therefore, the saving is 90 minus 30 multiplied by 1400 kg multiplied by 16 hours per day. So, if you calculate the calories, is 13,44,000. These are calories per day. Therefore, monetary saving divided by 540 multiplied by 1.5 is 3,733 per day. Where 30 degrees Celsius is atmospheric pressure of feed water, 540 kilocalories per kg is a latent heat of steam, atmospheric pressure, and 1.5 is the cost of steam per kg. Already I have shared with you that we normally take a 2 but this is a worst case scenario that let us take 1.5 rupees. So 3 kg steam is required to transfer 1000 kg condensate. The cost of operating system, operating pump, 5 multiplied by 60 multiplied by 1.5, that is rupees 120 per day. Total saving minus operating cost, therefore saving is 3733 minus 120, 3613. Next. Just go to the previous one. Therefore, the recommended implementation of steam energy conservation pay itself back is 1,60,000 plus for 1,46,800 divided by 3613 in 85 days only. So that comes out to be 85 days. So most important part is that when you are doing this particular system, not only you are getting the energy, you are saving the energy, but the cost also of your operating cost of this entire system is also getting reduced. And long-term basis, if you look at, we say ultimately the bottom line of your company is getting improved. Next. This is steam energy, what we call it as a, this is another, this thing project actually, which is they were using, basically the main product is basically they say milky maize. That's a kind of a product which they have got. Now they have got 5-stage dryers and 5 numbers of steam trap module, which has been installed for a proper condensate removal. And steam trap module has been online cleanable strainer, which has been given to that, so that no leakage, no choking of that particular part with a double glass window, actually, which has been provided. The total investment for this trap module is around 1 lakh rupees. Efficient steam trapping and condensate removal. So no need of open bypasses. Now, the steam operated condensate return system, which has been installed to recover the 1200 kg condensate per hour from the dryer at the maximum available temperature. Most of the similar plants, the condensate being drained. Here, this system has been installed. So, investment of condensate recovery system for 1000 kg per hour capacity is 1,36,550. Now, let us calculate saving. There was one question, no? Somebody asked that question that how to calculate that particular part. Here is the calculations which has been given, saving over there. So condensate is recovered at 90 degrees Celsius. Now you need to also, many times we have seen that people don't do the monitoring properly. That means the temperature, flow, all these kind of things are very, very important part, because unless and otherwise you do that, your actual costing you may not be knowing. Gone are the days when you are saying that guesstimate is that I get this much of quantity and this is my cost. So that kind of things. Now saving condensate recover at 90 degrees Celsius instead of 30 degrees Celsius. If you take, therefore the saving is 90 minus 30 multiplied by 1000 kg multiplied by 16 hours per day. So 9,60,000 kilocalories per day. Therefore the monetary saving is 9,60,000 divided by 540 multiplied by 1.5. The total saving is 2666 per day. 30 degrees Celsius atmospheric pressure, so feed water tank, and 540 already mentioned. 3 kg steam is required for transferring 1000 kg condensate. The cost of operating steam operating pump is 3 multiplied by 60 multiplied by 1.5. So 87 rupees per day. Total saving 2666 minus 72 is 2594. This is what the savings are per day. Now plant has got this particular part, plant has got 3 cookers to cook the corn and total 50 batches being cooked per day. After every batch, the excess steam is 2 to 2.5 bars. Pressure was vented directly into the atmosphere from the cookers. So at the time of there, where the two issues, again noise part and the steam, steam and heat, which was lost. Next. Now, what is more important thing is that as I said, that the vent silencer from them to stop the noise and recommend them to recover this particular vent steam also to generate the hot water, which is again used into the boiler filled water tank. The installation was done with a vent silencer, all 3 cookers brought to the individual line from all the 3 vent outlets up to the hot water tank and to generate a hot water. Now, apart from that condensate and other things, this is also being done. Investment of condensate return system is 800 kg per hour capacity, 1,35,000 rupees. Saving the 500 kg water being heated at 30 degrees Celsius to 80 degrees Celsius from very vent of the batch. That is every vent of this particular batch. So therefore saving is 80 minus 30 multiplied by 500 kg multiplied by 50 batches. See, when you are accounting this particular part, you have to take the entire production into the account. So 1,250,000 kilocalories per day is actually we can say that was saving, and therefore monetary saving, if you take it 1250,000 divided by 540 multiplied by 1.5, so it is 3472 per day. Again, the same kind of calculation has been done. So therefore, recommended implementation of steam energy conservation paid itself back 1 lakh plus 99,100 plus 1,35,000 divided by 2061 plus 1041 is 108 days only. So this is something, we always say that the payback period is 7 months, payback period is 2 months, sometimes it is 3 months, maximum it is 9 months, so very worst is 11 months, like that. Next. This is another case study. Why I am sharing more these case studies? Because your basic understanding, I have shared with you what systems we intend to use it and how we design it and what is the principle of this and philosophy of this. Now these are the actual being implemented and this is actual saving, not only being calculated out, but these are the repeat orders the organization is getting. Now this is a company called Transpec Silox. This is in Silvassa, that is Union Territory near Vapi in Gujarat. Now before recommended implementation, this was air energy conservation. 10 numbers of air receivers were there, 8 numbers of moisture separators for air were there. Now there are drain valves of air receiver and moisture separator kept crack open. The continues to remove moisture and air is getting wasted continuously. Now this is not really the thing, but this is again a part of energy conservation, how we can do that. Already I shared with you enough this thing about the condensate recovery part also. So a float type of compressed air trap has been installed for 2 numbers of air receivers and 1 number of moisture separator for a proper moisture removal. Now float type of compressed air trap is designed as a complete solution for draining the moisture from the compressed air receiver. And the FCAT is complete. This is a complete system itself with the water is being allowed to drain and the air is prevented from going out along with the water. So whenever air is trapped inside the float trap, the same is sent back to the system and through this particular balancing mechanism of air disposal bulb and thus the maintenance system at equilibrium with a air receiver. Now total investment of 3 numbers of this particular system along with 1 moisture separator is 80,000, that is 30,000 plus 50,000. Saving air which is getting wasted through the cracks open drains. Now how we have achieved the savings through by using float type of compressed air trap module compared to the timer based pneumatic drain valve. How it has been done actually. A little bit different case study also for all of you. So considering all the three drain points, which are half inches wall, which is kept crackly open, and minimum air pressure is around 10 kg per centimeter square. So if we consider only 4 mm orifice of a crack open wall and plant running on 12 hours only, the air loss per hour is around 12 hours or 60 minutes multiplied by 84 SEFM and multiplied by 3 drain points. So it is 1,81,440 per day. Now, where from the standard table, if we are considering, then flow through a 4 mm orifice is 150 psi, that is 84 SCCFM. Rate of compressed air is 0.03 per SCF. Therefore, saving is 1,81,440 multiplied by 0.03. That is 5,443 per day. The recommended implementation of air energy conservation pays, it is saved back, say around something like 80,000 divided by 5,443. That is 15 days only. So identifying where you are losing the money next. Where you are losing the money. This is a very small, actually a case study for use of online strainer for dry steam optimization. Now consider a cost of steam, say rupees 2 per kg. Steam pressure is say 3.5 kg per centimeter square. Steam flow is 1000 kg per hour. Existing dryness factor is 80%, say 0.8. Now online strainer can increase the dryness fraction to at least 90%. So ideally we say 98%, but say at least 90%. Now saving possible by using online strainer actually is latent heat at 0.8 dryness and 3.5 kg per centimeter square. That comes out to be 506.85 multiplied by 0.8 is equal to 405.48 kilocalories per kg. So the heat requirement in kilocalories per hour is 405.46 multiplied by 1000, that is 40,000, 4,54,000, sorry. So it is 405480. Okay. So latent heat 0.9 dryness and 3.5 kg per centimeter square. That comes out to be 506.85 multiplied by 0.9. So 456.16 kilocalorie per kg. Now, if I look at the consumption of steam at improved dryness factor, it is 405480 divided by 456.16. It is 888 kg per hour. So therefore, saving of the steam is 1000 minus 888. That is 112 kg per hour. So money saved is 112 multiplied by 2. That is 224 rupees per hour. Therefore, for a 24 hours running plant, use of online strainer is straight away, you can see that is per year, it is 19,62,240 per year. You can see that key from these case studies, because I did not wanted to share only with the theory or that kind of things with you. I wanted to share with you a live case studies which has been implemented, and where the question was that how you are monitored. So this was monitored actually, and whatever was thought, I would say that here and there maybe 2 to 4% deviations could be there, but actually they have got this payback period, and that's why the company has always gone for different kind of plants also. Wherever expansions were there, they have gone for repeat orders, or they have added some boilers, they have gone for similar kind of systems again. Most important part, what I have learned in last 35 years is that to get a client, it takes 3 months, minimum 3 months or average 3 months to get a client. To lose him, it takes a few minutes. Now, very important part is that what you commit, you deliver, and don't have high kind of, what do you say, achievements. Rather than that, we have been conservative on that part of achievements. As I said that 72% condensate recovery is quite possible practically, but we know that we can achieve it even 80 to 85%. 82 to 85%. Okay, problem chair? Thank you. So that is the thing. This is what I wanted to share with you. So rather than talking about theory, or talking about the philosophy, already I have shared with you what principle we have done this particular part, and we have an R&D also. We are based at Vadodara, Gujarat, and we have this particular plant which has been fabricating all these particular equipments, everything. And of course, we have learned from the initial our mistakes, and we have improved on. As I said, that we can guarantee also that 80 to 84% we can have a condensate recovery, but making that particular higher, many times it happens that the industries also don't share actual data with us. So we try to measure it with our people and our measurements, our team at site. Normal procedure is that for doing all this kind of assignment is that first we visit the site, we understand their boiler, that means all the data of boiler, whatever they are saying. We look at their logbooks, what they are maintaining, all the records kind of thing which are there. Actually, we look at it. Then we look at the present system of what they are doing with condensate, what is the recovery they might be doing that particular part. And normally, I can say that 80%, I have an experience that my clients throw some figures to me or to us, to our team or me, that we have 60 to 64% like that condensate recovery. And we have found that the condensate recovery is hardly any sometimes, or it is, if it is so, it is less than 30% also. So it doesn't comply, that kind of things, actually, that what they say. And frankly speaking, I'm an engineer and chemist both. So I got a lot of advantages. I understand the effluent chemistry also, out of the water chemistry also, and I also understand the engineering aspect of it. Because somebody gave me a challenge that you are not an engineer. When I did my graduation from Mumbai University in chemistry, he said you're not an engineer, so you won't understand PNIDs. So I was really angry, but that was a fact actually. So I took that fact in a positive way, and I got an admission into industrial engineering. So I got into industrial engineering, and then as my part of curiosity, I got into what is steam, what is condensate, what is effluent, what is water, what quantities water is required, what types of boilers are there, then what is the boiler efficiency, all these things. Because when you conduct an energy audit, there are two aspects of energy audit. One is electrical audit, and second is thermal audit. So this particular aspect falls into thermal audit. Of course, electrical audit, I think you must be having some sessions already being conducted or maybe planned next actually. But apart from electrical, thermal, I felt that the real, you should know what you are doing and why you are doing. So with this particular experience, I can say that we have learned a lot. We have implemented this particular system in more than 1,700 companies in India as well as in abroad. We also export these systems to abroad. There are a lot of other companies also like Thermax, Spirax, and a lot of other companies are there with whom we say that we compete. But in terms of we being smaller, we felt that we are more preferred by the industries because our cost is low, the overhead expenditure is also low, and we start with a free visit, many times to free visit to the industries for understanding and assessing what kind of potential saving is there into that company. That's all from my side. If you have some questions, you can ask me.
Sir, there is one question.
Yeah.
Are check valves needed at trap outlets?
Can you repeat that again?
Yes, sir. Are check valves needed at trap outlets?
Not needed.
And sir, second question is this. Is it okay to connect outlet of strap with different pressure to the same return line?
The differential pressure will create a problem.
Okay, sir, that's it. These are the two questions.
Thank you very much. Thank you for your patience also.
Thank you so much, sir. Indeed, it was a session filled with knowledge. And sorry, sir, for taking your name wrong earlier. I apologize for the same.
Absolutely, no problem.
Now I request Professor Chetan Rani to give vote of thanks.
Thank you, madam.
It is my privilege to propose a vote of thanks on this occasion. I, Professor Chetan Rane, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of Organizing Committee of AICT AQIS, sponsored online one-week short-term training program on recent trends in the energy management and audit, and my own behalf, extends a very hearty vote of thanks to Dr. Pradeep Joshi for accepting our invitation as a resource person and sparing his valuable time with us. He has given a good insights on the topic of current scenario, then why condensate water should be recovered and used again, then features of condensate return pumps operations, difference between electrical pumps and condensate return pumps, flash and condensate recovery system, steam operated condensate return pumps and operations, steam separation flash vessels, steam trap models, and also he shared 6 case studies with us. Thank you so much, sir, for sharing your valuable knowledge with us.
Hope this will give an insight to the all mechanical engineers to get excited into entering into this steam sector. And energy
Yes, sir,
saving.
definitely.
Yes, sir, definitely.
Okay.
Okay, I would also like to remind all the participants about tomorrow's session. Tomorrow, 5th November, morning at 10 a.m., we have 7th session by Dr. S. Jagdiswaran on the topic exercy analysis. I request all participants to join the session. Thank you so much.
Thank you.
Thank you, Joshi, sir.
Thank you, sir.
Now we will
I
end
would
the
like
session.
to
Yes.
end the session, please.
कॅल्क्युलेशन सांगितले ना माणूस वेडा होतो त्यांना आणि
Hello. Okay.